702.
The Naked Scientist.
And your calls have started to flood in already. 011-883-0702. Speak to us. Ask your question to the Naked Scientist. That's Dr. Chris Smith. Every Monday, just after 2:30. Some of your questions already in. Hello, Chris.
Hi, how you doing?
I'm very good, thank you. Pubs are open over there. Is everybody happier and with the spring in their step?
They were calling it Super Saturday, and we were hoping that people wouldn't abuse the privilege and lead to enormous numbers of outbreaks of coronavirus. Well, we'll find out in 3 weeks' time, because it takes about 3 weeks for the numbers to begin to trickle in. So hopefully it's all going to be okay. But no, I mean, I think people are just very, very, very stir crazy because we've got cabin fever. Everyone's been confined to barracks for too long, and they want to get back to normal.
Yeah, exactly. At great risk, we must add, if you don't observe, all of these guidelines. So let's get to it. We've got quite a few questions in already. Lee says, please ask Dr. Chris how the mesh screen on a microwave door prevents microwaves from escaping and harming the user.
Hello, Lee. The answer is that light comes in waves that are different sizes. And while microwaves are one form of light and visible light is a very different form of light, the thing that sets them apart is how big the waves are. And I don't mean how tall, I mean as in how far apart they are, how closely spaced. Visible light are much more closely spaced than microwave waves. The wavelength, which is the distance between the start of one wave and the start of the next wave, in visible light is absolutely tiny. It's, for instance, if we take red light, which is a good example, that's sort of 600 nanometers. If you take a microwave oven, the distance from one wave to the next wave is about 10 centimeters. So huge. Okay. So therefore, if you put a grill on the glass, the microwaves, being very, very big waves, will actually see the grill as a solid piece of metal and they won't come through. But the tiny, very tightly spaced visible light will come straight through because the holes mean that they can easily come through. There's no problem with light being absorbed by the metal. So visible light can come out. You can see what's going on in the cooker, but the very widely spaced big microwaves get absorbed by the metal in the grill and no microwaves filter out into the room.
That's so clever. That is so clever. We can see what's going on in there, but we also protect it at the same time by virtue of the size of that mesh. Lee, fantastic, fantastic question. Ginosi has given us a call, didn't want to come on, but says, what is aphantasia and can it be cured?
Aphantasia. I don't know. It sounds like a particular word for something. What does it mean? I don't know the word.
Aphantasia. Yeah. Am I saying it correctly?
I'm going to have to. It sounds like one of these words, like pagonophobia, which means fear of beards. I don't know what the word is, and so I can't answer the question. I'll have it as homework. Let me find out for you for next time, and I will come back. I'm very sorry, I don't know what the word means.
All right, that's perfectly allowed, and we'll do that next time with Chris. Kinosi, not today, but the next time. Let's go to Andrew in Hammanskraal. Hello, Andrew.
Hello, Azania.
How are you?
Dr. Chris, hi.
Hello.
A lady asked last week, one lady asked on last week's program, what's the distance between Earth and Mars?
Yes.
I might have the answer to that.
Yay, that was also part of the homework.
It was.
The answer, Andrew?
Yeah, go on. What's the answer?
The answer is 78 million kilometers.
78? You said billion.
Million, M-I.
Oh, million kilometers. Chris, your answer to that?
Thank you very much for doing my homework for me. So there you go, sir. I'm sorry I'm late with this, but I got him to do it for me.
Yeah. Okay, your check's in the mail, Andrew.
Thank you.
Thank you. I don't know, I expected, or maybe I'm being... Andrew, you say 78 million, and I don't know, my mind always struggles to think
it varies, right? And the reason it varies is because the Earth is on a tighter orbit closer to the Sun. Mars is on a greater orbit, so they're not going around the Sun at the same rate in sync. Mars takes longer to complete its journey because it's got further to go. Therefore, at certain points, the Earth is going to lap inside Mars, and there will be certain arrangements where the Earth and Mars are quite close together. And that distance, the separation, the record closeness is in, I think it was 2003, I think, when we were closest, and it was very, very bright and red in the sky. And then it was about 55 million kilometres. Obviously, if you're around the other side, you've got a much greater distance because Mars is on one side of the sun, you're on the other. It would be way more than that. But the closest and the time that we try and strive for, if we're launching space probes to Mars, for example, is when actually the Earth and Mars are on about the same patch of sky. So in other words, the Earth has come round, Mars has come round, and the two are lining up across the solar system because all the planets go around the sun as though they're on a flat disk. And so you try and arrange it because then it's the minimum travel distance and travel time between the two bodies. But the minimum we've ever measured, I think, is about 55 million kilometres. So Andrew's right ballpark.
All right. I'm struggling to think in millions of kilometers, but my head I'll find a way to wrap my head around that. Someone has, it's an unsigned WhatsApp, and it says, aphantasia is a mental condition characterized by an inability to voluntarily visualize mental imagery. Many people with aphantasia also report an inability to recall sounds, smells, or sensations of touch. Some also report prosopagnosia. Prosopagnosia,
yes. Which means you can't
the
recognize faces.
To recognize faces,
yeah.
Yes. I'm a super recognizer, by the way. I did a little test. One of those people can remember faces. So, yeah, that's a description of aphantasia.
We actually covered a study on the Naked Scientist podcast last week about a gentleman. This was published in the Proceedings of the National Academy of Sciences, USA. It was a patient called RFS. They tend to use the patient's initials when describing patients with medical conditions. This individual cannot see the numbers between 2 and 9. So they can see the number 1 and they can see 0, but they cannot see any of the numbers in between. This is a newly acquired condition for this person. They used to be a geologist, an engineering geologist, so obviously they realised there was a problem. They have done various experiments showing this gentleman the various digits and things. And when he looks at a number, all he sees is a tangled mess of spaghetti. Why are 0 and 1 exempted? Well, probably because they're letters as well, L and O, or I and O, and so they can probably be decoded via a different part of the brain. But it looks like the numerical circuits in his brain have been damaged by a degenerative disease. So he's lost the ability to actually interpret and turn a shape into meaningful information. He just sees it as squiggles. And if you put something else meaningful inside the number, so if you take the number 8, it's got 2 holes, 2 circles, right?
Yeah.
If you put something in the circles inside the 8, like a face, he can't see the face either because it all becomes merged into the jumble. So it's very interesting. It's amazing how when you get somebody who gets some kind of problem with the nervous system, how it can reveal the clever intricacies of how the nervous system actually works and processes information.
That's so fascinating. So seemingly that's the definition. So maybe we'll get a chance to explore this condition a little bit more. Ronnie's been listening in with the question as well. Hello, Ronnie.
Hi, how are you?
Good, and you?
Good. I just wanted to ask, because I've been fortunate enough to see a few falling stars in my time, and they fall out the sky so fast. I'd love to know what speed they're traveling at.
Okay.
Well, it's all going to depend to a certain extent, Ronnie, because it depends on the trajectory they're coming in at and what they were doing speed-wise before they fell towards the Earth, but they're certainly going to accelerate under gravity. Some of them may be passing by at thousands of kilometres an hour, but as they slow down, as they interact with the Earth's atmosphere, they will slow down a lot. Because the reason you see them as a shooting star and glowing is because of a process called adiabatic heating. And this is where, as they come in through the atmosphere, they are compressing the air very hard in front of the thing because it's moving so quickly. And if you compress air very hard, it gets very hot and you make the air glow. And that's why it's not actually the thing burning up. That's a myth. It's the compression of the air in front of the object. But obviously, if you're doing work against the atmosphere, you're slowing the object down quite considerably. So they may have an initial velocity, which is extremely high, but then as they come in through the atmosphere, they're encountering thicker and thicker atmosphere as they move down towards the ground. And this means because they're surrendering more energy, heating up the atmosphere, they are slowing down in the process. So there is no correct answer to this question, except that when they're out in space, they're doing a very high speed. When they hit the ground, they're doing no speed. And in between, they are losing velocity rapidly as they come in through the atmosphere. And they may fragment and then fall into dust before they even get to the ground anyway. Some make it down to the ground, of course.
Yes, remember a few years ago, Russia. Remember, I think that was a meteor.
Oh, the
Meteorite.
Chelyabinsk impactor, which
Yeah,
landed
yeah.
near Chelyabinsk, and it fragmented into multiple pieces high into the
Mm.
atmosphere and created sonic booms as it did so, and smashed lots of windows. And they did actually work out. There was quite an interesting paper. People were able to get recordings that independent people had made on things like car dash cams, mobile devices, and so on, work out based on the landmarks and the arrival times of sounds that were on those recordings, where
Wow.
the object came from, what its trajectory was, where it fragmented, and then ultimately where some of the pieces went. And they actually went and found in Lake Chelyabinsk, they found a big hole in the ice. And it looks like this object, at least one part of that impactor, went straight through the ice and is now sitting at the bottom of Lake Chelyabinsk.
Oh, wow. Okay, that's going to make some fascinating study, just as in what's in there, what the components are of that piece. Let's go to Maputa calling us from Hartis. Hello, Maputa.
Hello, Adani, how are you?
Good and you?
Listen, why is it easier to reverse into a parking space than sometimes driving into that space? I'm not talking about side parking. I'm talking about at a shopping mall where I need to reverse into a parking space. I find that it is easier to drive into that with reverse than
Yes.
driving straight into that. Or is
Okay.
it just me?
So nose parking, as in the nose first of the car, is harder for you than reverse parking.
Yes.
Okay.
Yeah.
Chris, yeah?
Well, think about when we reverse, you then use the steering of the car on the wheels at the front of the car to actually swing the front of the car so that you can then point the direction you want it to go in the right direction. So actually it's quite easy to park in that way because you're then swinging the thing that's steering is also doing most of the movement. Whereas when you are driving into a parking space, you are steering with the thing that is at the front and you want the back to actually come round. So you've got to make a better correction. You've actually got to judge in a different way. It's easier to judge when you're reversing because you have an easier calculation mentally to do about where you're going to swing the front of the car to make it park correctly. When you're driving straight on into a parking space and you've got to swing out into an arc, you have to take into account the fact that the back of the car is going to follow a different course to the front of the car and you need to make a wider arc. When you get experience, if you watch a person who drives trucks and lorries, they're really good at doing this because obviously they've got to take into account the fact that they have a trailer on the back which is going to follow a different course to the tractor that's pulling it on the front. So they get very, very good at this. But for your average car driver like me, we all make that mistake and don't judge correctly what the swing angle is going to be until you realise that's what
Right.
you're doing wrong, and then you can park easily driving straight in if you learn to take that into account. But most of us don't do it enough and we learn, oh, it's easier to do it in reverse because it's easier to compensate and correct, and so I'll just reverse into the space.
I don't know if I'm going to say this properly, and it's not even going to be in a scientific way, but is there a varied point, of course, in that turning point of a car? Of course, like if you look at a car as a block, is there a point that would be different, say, on a hatchback and on a sedan, for instance, those big sedans, as to where that point is when
Yeah.
you move from being at the 90 or at the 180 degree to the 90 degree? Do you know what I mean?
If you've got a bigger car, it's going to be harder
Yeah.
to park than if you've got a much smaller one because you're doing a
Yes.
bigger mental calculation. You're compensating for a bigger vehicle footprint, and the car is also going to take a slightly different trajectory. Also, depending upon where the wheels are relative to the front and back of the car that you're steering with,
That's
because the
it.
closer those
Yeah.
wheels are to the point of turn, then it's going to affect how the car swings. And also being used to the vehicle. If we get trained on how to drive, I mentioned lorry drivers, bus drivers, the same. With that sort of training and practice, you learn to take into account all these factors, and it happens subconsciously in your mind. But when you get behind the wheel of a new car, or until you've practiced doing this sort of parking a lot, it doesn't come as second nature. The most fancy parking I ever saw, there's a guy who, there are lots of these people who do this, but there's a guy who drives minis and actually drives at full pelt down the road and then does a handbrake turn into a parking
the
space
parking
parallel
bay.
to the pavement and swings it in with perfection between two parked cars. I expect his insurance premiums are quite high.
Yeah, no, I've seen some of those videos. Oh, they're slick. They're slick. And
I know, it makes you
you're
sick, doesn't it,
nervous,
to
you
watch
hold
them?
your breath. Yeah, you hold your breath. Then there, perfect fit. Here's another question, and it says, why is water and oil considered an immersible, meaning they don't mix? Would I be wrong if I say water and oil mix? This comes from Leah.
Hello, Leah. Water and oil are immiscible. They won't mix because they have very different chemistries. Water molecules are what are called polar molecules. They have a dipole, and that is science speak for one bit of the molecule is a bit plus and one bit of the molecule is a bit minus. And this is because oxygen loves electrons and hydrogen doesn't care so much. So the hydrogen electron in the water molecule spends more time close to the oxygen than to the hydrogen, and this makes the molecule have this asymmetry, with the oxygen being a bit more minus and the hydrogen a bit more plus. This actually makes the molecule quite sticky, and so it tends to attract other sticky molecules that are charged in this way, and this gives water some of its extraordinary chemical properties, which is why we have water behaving the way it does and doing this thing called hydrogen bonding, where the slightly positive hydrogen is attracted to the slightly negative oxygen of the next door molecule, and this makes water sticky. Oil molecules don't do this. Carbon makes 4 bonds and tends to distribute the charge fairly evenly across the molecule, except when you put groups like oxygens on there, which are more electron hungry. And so most oily molecules tend to be uncharged in that way. They don't make those dipoles. So as a result, the oily molecules don't like the sticky electrically charged molecules. So the oil molecules go where there are other oil molecules, the water molecules go where there are other water molecules, and the two don't like mixing, and that's why you get an immiscible liquid. And if you want to make the two mix, you use something like a detergent or a surfactant molecule, and this is an oily part of the molecule with a highly charged bit on one end. And what that does is enable you to drag the oil molecule using the oily bit on your detergent close to the charged molecule, the water, using the charged bit of the surfactant molecule, and that's how you get the two together. And that's how detergent gets grease off your plates in water.
Nice. I'm glad you added a everyday example as well. And then another one says, how possible is a planet called Kepler in having alien life? This comes from Sabelo and Kagiso.
Well, the question about whether or not there's alien life is an open question. We don't know the answer to this, and the reason that we're spending billions exploring Mars is to try to get to the answer to that question, because it tells us a lot about where we all might have come from. There are lots of different theories about whether or not there's life in the universe. Most people choose to play a numbers game, and they say, well, if you look at the fact that there is the Milky Way, which is our galaxy, and there's maybe 200 billion stars in the Milky Way, like our sun a bit, and therefore there's possibly 200 billion times 5 planets in the Milky Way. And then you say, and there are 200 billion galaxies like the Milky Way out there, so that's 200 billion times 200 billion. That's 1 followed by at least 22 zeros, possible stars out there. And even if a tiny fraction of them were like our sun, and even if a tiny fraction of them had an Earth like our Earth, it means that the likelihood actually of their life existing somewhere in the universe is actually quite high. Whether life exists in our solar system, that's a different matter, and it may be that we're the only living entities here now, but it doesn't mean that there weren't other places supporting or sustaining life in the past, and it doesn't mean also that there aren't some moons around some other planets in our own solar system that might have created the right sort of environments for life to flourish. And people are very interested, for example, in Enceladus, one of the moons of Saturn, that because of the way it gets twisted and buckled by the gravitational field of Saturn, this generates heat inside Enceladus, and we think is causing a liquid ocean to be there. And it may well be where there's liquid water, there is life. And scientists are actively pursuing that possibility as well.
As we part, you'll see something that Bentley Mdafu has shared with us, truck reversing, saying he absolutely agrees with your answer to that reverse parking question. And then another one from Sibusiso, and he says, please ask the naked scientist to confirm the longest English word. I don't know if this is a science question. Maybe you know it.
I think it's anti-disestablishmentarianism, I believe, is the longest in the dictionary English word. I think that's the one that's the current record holder, anti-disestablishmentarianism.
Wow. Okay. When we were kids, we used to think it was califragilistic.
Oh, supercalifragilisticexpialidocious. But that was a little bit of a contrived one, wasn't it? And there was the newspaper headline about Celtic, and it was supercaligo ballistic. Celtic are atrocious was the newspaper headline when the two teams played each other.
Brilliant, brilliant.
Till next time.
Yep.